Hi there everybody, Miss Nardini here. Today we're going to be graphing absolute value functions. So the first thing we're going to do is look at the parent function, y equals the absolute value of x. Knowing what this graph looks like and its different attributes, we can talk about other types of absolute value functions. So the first thing I want to do is graph this, and I'm going to use a table because we can graph anything, any function using a table. So I'm going to choose a couple negative values, 0, and then 1, 2, and 3. So I have some positive values. So remember, all you're doing is taking your x values and substituting it in to find y. So the absolute value of negative 3 equals 3. And the absolute value of negative 2 equals 2. So I would like you to take a second, just substituting these values in. Pause the video, please, and see if you can fill in the rest of this table. Hopefully your table looks just like mine, not too difficult. Then to see what the graph looks like, we just need to plot the points. So I've got negative 3, 3, negative 2, 2, negative 1, 1, 0, 0. And I've got 1, 1, 2, 2, and 3, 3. And I can graph the two different parts. So it is true that an absolute value function will always look like a v. But there are different things we want to notice. Well, in this one, we'll note that our vertex right here is at 0, 0. We care about how it opens. In this case, it's opening up. And we call the shape here standard. And we'll go more into that in a little bit. So the general formula for an absolute value function is y equals a times the absolute value of x minus h plus k. And the few things that we need to know, our vertex is at h comma k. So hk, up here in our parent function, there was no h and there was no k. So this is kind of like x plus 0 plus 0. So that's why our vertex is at 0, 0. When we talk about how it opens, it's either up or down, depending on whether a is positive or negative. I think you can all probably guess. If it's positive, it opens up. If it's negative, it opens down. And then we talk about the shape. We have wide, we have standard, and we have narrow. And we already looked at standard up here. Well, there was no a here, right? That's because it was like 1 times the absolute value of x. So anytime that number in front a equals 1, well, we really talk about the absolute value because we just care about the number. The positive and negative tells us how it opens. The absolute value will give us the shape. So if it's equal to 1, it's standard. If the absolute value of a is less than 1, it's wide. And if the absolute value is greater than 1, it is narrow. So once you have that all written down, we're going to move to the next problem. So we've got y equals negative 2 times the absolute value of x plus 1 minus 3. So the first thing I want to figure out is my vertex. Well, remember it's h comma k. And here in our general formula, it is x minus h. So if we had x minus a negative 1, we would see that h is negative 1 and k is negative 3. It's true that our x coordinate is always opposite. Now, and y is always the same. We can talk about how it opens. I'm going to erase it up here. I have a negative 2, so it's negative, so that means it's going to open down. And then we do have to talk about the shape, but we'll talk about that in just a minute. So if I want to graph this, I'm going to use a table once again. I like to start with my vertex. I have negative 1 and negative 3. I like to choose a couple x's smaller, like negative 2 and negative 3, and a couple x's bigger, like 0 and 1. And then we need to plug those values in, substitute that x value in. So I've got negative 2 times x plus, negative 3 now is x plus 1 minus 3. And if you do that, I'll show you my work. Negative 2 times the absolute value of negative 2 minus 3 is negative 2 times positive 2 is negative 4 minus 3 is negative 7. So that's where I get that negative 7. So once again, I'm going to pause this, and I'm going to challenge you to fill in the rest of this table. So pause in 3, 2, 1, pause. I sure hope you paused to get the most out of this video, but if you didn't, it's not too late to make sure you can get all these values. So I'm going to plot the points. I've got negative 3, negative 7, negative 2, negative 5, negative 1, negative 3, 0, negative 5, and 1, negative 7. Oop, that's a bad line. But let's make sure we draw a nice, pretty graph. And here we go. So we can talk about the shape, right? If you look at it compared to our original up here, we can pretty much, by looking at it, say it's narrow. Or we could remember that anytime the absolute value of a is greater than 1, we have a narrow graph. And the absolute value of negative 2 is 2, which, yes, is bigger than 1, so it's narrow. So there's two different ways you can figure that out. So let's take a second to fill in this little table I made for us. How does A change the graph? Well, it changes the shape. And it tells us whether it is up or down. So that number in front of your absolute value sign gives you the information about the shape and its orientation. What about H? How does H change the graph? Well, it moves the vertex left and right. Remember, it's the x coordinate, so it's moving it left and right. So similarly, K moves the vertex up and down. So it's pretty much, well, it's not necessarily just moving the whole vertex, but it's moving the whole graph. But since we plot the vertex first, I like to write vertex. So once you have that written down, I'm going to show you a shorter way to do it instead of using a table every time. So first things first, if I have a negative in front, what does that mean? It means that it opens down. And then I look at that value. It's a negative 1. So if it's a negative 1, the absolute value of negative 1 equals 1. So that tells me that the shape is standard. And from the rest of the graph, we can look at the vertex. So inside I have a negative 1, so that means my x-coordinate is positive 1, positive 1. So the first thing you should do is plot that vertex at 1, 1. And then here's my little trick. We know that it's opening down, so we just have to make sure our graph is actually opening down. And with that negative 1 in front, I kind of treat that like a little bit of a slope. So if it's negative 1, I'm going to go down 1 over 1 to get part of my graph. And then the reason I say kind of a slope is I'm going to go down 1 over 1 but in the other direction because I know that my graph has 2 legs. So that's my shortcut and we're done. So remember, we know that this is standard because the absolute value of a equals 1. And then this part of my graph is, I'm going to put quote unquote slope. It gives you the 2 different legs. So let's look at number 2. How does it open? Hopefully well said, up, because this 3 is positive. And then the shape is narrow, because the absolute value of a is greater than 1. And if you plug 3 in here, that works. And what's the vertex? So I have 4 inside my absolute value, so I have a negative 4 x value, negative 5. So let's plot that point, negative 4, negative 5. And then I'm going to look at my slope of 3 over 1. So I'm opening up, so I'm going to go up 3 over 1, up 3 over 1 to get half my graph. And then I'm going to do it again, but I have to go the other direction. Up 3 to the left 1, and there is my absolute value function. So it shouldn't take too long to graph it once you get the hang of it. And if the shortcut is confusing you at all, please rewind, rewatch, and figure that one out. If not, you can always use a table. Whatever you desire is the best way to go about it. So number 3, I would like you to do this on your own. Make sure you come to class the next time we meet with this graph. All this stuff filled in and the graph fully completed, and we'll talk about it when we see each other next. See you then.